Okay, well, hello everyone. We're at the top of the hour here today. I'd like to go ahead and kick things off. My name is Gabe Prado. I'm the product marketing director for Cognite, focused on power and utilities. And on behalf of both Cognite and WinSim, I'd like to welcome you all to our webinar, Enabling Flexible, Efficient Transmission Operations. So thanks again for showing up today. We'll jump right into things here with a little bit of housekeeping. First thing, we will be collecting questions throughout this webinar. So if you have a question, go ahead and put it in the question box and we'll address as many as we can at the end of the webinar. We also will be recording everything and we'll make sure to send out and distribute this presentation within a couple days. And then if you have any questions about either company, feel free to go to our website, www.cognite.com or www.winsim.com to learn a little bit more about us. Jumping right into the agenda, I'd like to kick things off here with a few introductions to the panel. We'll spend some time talking about the business case for flexible transmission operations. Spend a good fair minute talking about the emerging application space and some of the approaches that are being used to solve this problem. Go through, what's required from a scale perspective and a data perspective, and then spend a little bit of time at the end just talking about getting started with WinSim and Cognite. So I'd like to go ahead and hand things over just to our panel real quick and give them a second to introduce each other or introduce themselves. So Charlton, would you give us a little bit about your background real quick?
Sure. Good afternoon or morning, depending on where in the world you might be, everybody. My name is Charlton Clark. I'm the Vice President of Business Development for WinSim. Prior to coming on board with WinSim, I was the Program Manager for Grid Integration in the Wind Energy Technologies Office at the U.S. Department of Energy, where I led a broad swath of research related to integrating large amounts of wind power into the grid. It's actually where the underlying effort behind WinSim's current new offering that we'll be talking about was developed. Prior to that, I was with the Federal Energy Regulatory Commission for several years as an expert witness testifying in FERC hearings before administrative law judges.
Thanks, Charlton. How about you, Jake?
Hey, thank you. Looking forward to going through this webinar, but as you say, introduce myself, Jake Gentle from Idaho National Laboratory. Been here about 11 years, program manager and also relationship manager for our wind program, R&D program here. Power systems engineer, background is control systems, actually. Been applying that to power systems for over 10 years, I suppose. Leading a lot of new cybersecurity projects for renewables, mainly wind, solar storage, electric vehicles, microgrids, et cetera. Looking forward to seeing some of this technology make it to market as the kind of the original innovator behind some of the solutions that WinSim is going to present today in partnership with WinSim through the last, 5, 6, 7, 8 years. Really excited about this. I think this is the role of a national laboratory, launching products, and we're happy to see it hit the street.
Great, awesome to hear, Jake. And then last but not least, Francois, love to hear about your background as well.
Hello, everybody. I'm very excited to be here and be part of that product launch with WinSim and with the Idaho National Lab. My background is computer science, computer engineering, working in aeronautics, and I joined Cognite very early on, and I've been working with scaling data-driven technologies for very large industries, whether that's power and utility or energy or manufacturing and transportation. So very much at the heart of what we're doing, and very, very excited about what the innovation that Charlton and Jake are going to talk about and present today.
Great. Well, thank you so much, all of you. So real quick, kind of hand it back to Charlton. Love to give a quick introduction about WinSim. So what can you tell us about WinSim?
Sure. So, a little bit of the company background. So we were first established in 1993. Our core focus has been applying computational fluid dynamics, mostly in the area of wind farm development. Fundamentally, what we do is help work with wind farm developers to figure out the most efficient way to lay out their array of turbines for a given wind farm, try to maximize their power production. We are headquartered in Norway, but we do have a few other offices throughout the U.S. Main office, like I said, headquarters in Norway, but also one in California as well as one in China. and satellite offices now as well in Idaho Falls and Tucson, Arizona. We've got quite a bit of experience working across the spectrum of wind farm developers. About 30 or 50 different partners that we've worked with throughout the years. And here in a few minutes, we'll get into a little bit more detail on exactly how WinSim's capabilities merged with the concept that we came up with for dynamic line rating and created a perfect marriage between the two.
Great. And then a little bit of background on Cognite as well. Francois, what can you tell us about Cognite?
Sure. Interestingly, also a Norwegian company. There you go. Although we are all based in the US here. Born in Norway, working in heavy industry from the start. Actually, born out of industry. We came to be because large industrial players were struggling to scale their digital and data-driven initiatives. We're now a little bit over 450 employees, growing very fast. Probably one of the fastest growing software company in Scandinavia. We focus exclusively on heavy asset industry. So there's a list of selected clients there, but again, it covers power and utility, both generation, transmission, and distribution, and some renewables, but also energy, shipping, and manufacturing. We really deal with this challenge of scaling digital innovation for industry, and that has resonated from America to Japan through Middle East and Southeast Asia, where we now have a presence.
Great. Well, I think this is a really interesting, timely webinar. I know we announced the partnership a couple weeks ago, but I think it makes sense to jump right into the business case. What is the problem that we're trying to solve together? And Charlton, I think you've got some really interesting ideas here about this business case. Can you maybe fill us in?
Definitely. So fundamentally, what drove us to develop this approach to developing a dynamic line rating system comes purely from the fact that when wind farms are producing the most amount of energy, it means that the wind is blowing heavily. This leads to a concurrent cooling effect that happens across transmission lines, where depending on the angle, wind speed, amount of solar irradiation, and other environmental factors that are at play, you get a substantial cooling effect on transmission lines. So what this does is create a natural relationship between applying a weather-based dynamic line rating system and applying it in locations where there are large amounts of wind generation, because you get this wonderful effect where they benefit each other and you can create additional capacity. So we set out to develop a methodology to bring that to fore, and have spent the last 10 years or so working across a number of different pilot projects, testing out the methodology, refining it. And fundamentally, one of the key aspects that whenever we were doing this initial research, that we were happy whenever WinSim came along, is because their expertise in computational fluid dynamics allowed us to fill in the one real missing piece in this, and that is understanding all the different terrain effects and how when the wind is blowing through a large swath of area where you might have a set of transmission lines, without having to have a large, huge array of monitoring stations, we're able to basically model where the wind is blowing, how it goes through those different terrain effects, what the effect is, and translate that up and still be able to calculate exactly what the cooling effect tends to be on a transmission line. This is an important issue because there's a substantial amount of congestion that goes on throughout the country that increases price to consumers, decreases the overall reliability and efficiency of the transmission grid. And we want to be able to bring our solution to bear to help the industry unlock those bottlenecks and make optimized use of the existing infrastructure that we have.
Gotcha. So if I kind of heard you correctly, you were saying that your technology helps find those areas where there's a little bit more efficiency to be gained out of utilizing the existing infrastructure. Is that fair?
Yeah.
Perfect. Well, I think it also helps to really frame this in terms of dollars and cents. So can you share a little bit more about the financial impact that your solution provides to this market space?
Sure. So here's just a little bit of a snippet of one instance, something that I pulled from the Midwest ISO's State of the Markets report. This comes out basically every year, where they break down how the markets have been operating throughout the Midwest ISO region. But I found this very interesting quote, I thought, in the middle of the report, basically just talking about how there could be substantial savings across the board if transmission owners were to move to, we'd obviously prefer full dynamic line rating, but just bringing in more of these standard ambient effects that do affect the overall rating of a transmission line. And you can see over here on the right-hand side of the slide, there's a substantial amount of transmission congestion costs that get racked up in any given year. And this is just in the MISO region. If you expand this type of analysis throughout the United States, there's a rough estimate about $4 to $6 billion a year in additional congestion charges that are levied just because we're not making a maximized use of our existing transmission infrastructure. So once again, this just really shows what the economic and business case is for the application of dynamic line rating and the benefits that it can bring to the overall electricity markets.
Gotcha. Thank you. Now I'd like to kind of pivot the conversation to Jake here. I know, Jake, you're with Idaho National Laboratory. Could you maybe explain a little bit more about the role that INL plays in the development of this technology, and then talk a little bit about the approach that you guys are working on?
Yeah, certainly. So, the role of a national laboratory is quite simple, although it's complex at the same time. One thing I wanted to make sure to clarify here is dynamic line ratings, or line ratings in general, are not new. It's not like rating a line is innovative. That's not what we achieved, right? Line ratings have been something that's been around for a long time. I mean, since the invention of heat transfer. Someone who can define heat transfer, that's how you rated things with thermal mass. So at the National Laboratory, we've developed a handful of technologies. And some of those technologies were on the market prior to us talking about a weather-based dynamic line rating technology or methodology. And so for us, it's really looking at the gaps. What is missing in science? What is missing in industry that are large barriers, right? That the industry doesn't have the time nor attention, and maybe lacking some investment to overachieve some of those barriers. So when you talk about the role of the lab, what is it? Well, we identified that what was missing on the market and what was missing in some of the literature was the influence of environmental conditions on line ratings. It's not that it was unknown, it was just the lack of awareness of how much impact it would have, and how easy it could be to incorporate some of those environmental conditions into the way a utility operates their system by using DLR. So, you ask, well, what is a line rating? Well, again, Charlton mentioned a handful of these components, but effectively you got heat in, heat out. You have to balance, right? You have to operate your system without violating, say, distance to ground, step potential, other sorts of mechanically driven restrictions. So for this, looking at wind cooling or radiative cooling, because you've got lower air temperatures, less solar heating, allows you to move more current through that conductor. That's that joule heating, right? So you got to keep that heat balance equation happy.
Yeah, so there are also a couple areas to already increase the capacity of lines. Can you maybe speak to some of these methodology and some of these ways that exist today?
Yeah, and again, line ratings are not new, and dynamic line rating is not the first time somebody said, well, how can I increase the capacity of my existing lines? There's a lot of other approaches. You can adjust your static rating parameters. You can apply other rating approaches like seasonal or even ambient adjusted ratings. What we're really talking to you about is kind of the most effective, most cost-effective way of applying some additional rating techniques that get you the bang for the buck. But you could change the rating. You could use some of that clearance margin. You could allow a higher operating conductor temperature. You could fix clearance limits. And I've shown some pictures on the right where it's like, wow, you built a structure under a structure, right? And we're thinking of innovative ways. Well, sometimes that is the solution that comes up. You can reconductor. So the bottom right-hand picture there shows you a handful of different types of conductors. And high temp, low sag type conductors are hot on the market right now. But there are still limits, physical limits, land access limits, cost issues. So really, what we're talking about dynamic line rating for is you need to consider all sorts of options as you try and increase that capacity.
Gotcha. No, that definitely makes a lot of sense. I know that there's still some challenges that exist though, right? Like the data piece is one part, which we'll definitely spend some time talking through in this webinar. But like, what are some of the external challenges that still need to be faced for this methodology and this technology to really be adopted at scale?
Yeah, and again, with anything, change is hard. Just because you have more information at your fingertips doesn't mean you know how to use it. If there's more information, that means there's more, probably digital connections out in the wild, right? There's more information coming in. It had to come from somewhere, so there's a communication path. Some of the challenges is as we move deep into the automation, innovation, artificial intelligence, machine learning, you're now introducing a lot of things, especially into the electric utility industry, that the system wasn't really designed for, right? And so now you got to think about security, not just physical security, but cybersecurity. If anybody's following, what that looks like around the world, it's hot on it. So effectively, what I was referring to is challenges in cybersecurity. It's a global challenge. It's nothing new. It's not just a challenge for dynamic line rating. And there's a lot of mechanisms for you to ensure that security as you adopt new technologies. The benefits far outweigh the challenges. I mean, at the end of the day, that's what we're looking for, right? And so I think increased reliability and operational efficiency, you can overcome the small cybersecurity, physical security challenges.
Gotcha. No, that's great context. And I think there was one more little bit of information you wanted to kind of talk through here in terms of just computational fluid dynamics and really moving into a more global simulation model type approach. Can you maybe speak to that real quick?
Yeah, and this is where the innovation in partnership with WinSim really came from. And this is the ability to monetize increased capacity on your transmission infrastructure. And you think about this top-down approach where you're looking at global simulations, you're looking at data processing, coupling that up with local weather stations, and transferring that information with computational fluid dynamics. I mean, that's the process, right? And so from a global perspective, looking at line ratings does not mean you have to install a new weather station, install any sensors. The world right now is just rich with information. And so bringing that into a dynamic line rating solution really enables kind of a very quick look. It also looks at a very readily available, scalable methodology. And I think from a forecasting perspective, we're always trying to figure out where to place our money in stocks or wherever it is, right? So dynamic line rating is no different. Marketers and generators, they need to know, how can they best monetize their asset. This is really where we start talking about the innovation, and I'm really looking forward to seeing what Cognite and WinSim can do with this, because when you start blending the heuristics of information and big data with very sound technology, now you've got something very powerful.
Gotcha. Yeah, so it was really interesting to kind of hear you talk about this system of systems, right? And with systems of systems comes complexity that can be solved to many degrees with better software and better forecasting and better methods. So Charlton, I'd love to hear a little bit more about what's different about WinSim's offering, and how you guys are approaching it.
Sure. So what this slide basically shows is a example of our current graphic user interface, or GUI, which basically just displays various dynamic line rates across a series of transmission lines. So right now we've got this in this example, the middle line is highlighted, and the graph down at the bottom. Basically, what that shows is the black line straight across the bottom is the static rating. And then for this given week that we're looking at, the blue line that wobbles up and wobbles over the top of that is the dynamic line rate, or the dynamic rate for the line. So as you can see, that changes from hour to hour over the various days that we're looking at in this little snapshot. But this isn't just, we just magically calculate all this. Underlying all of this is a huge amount of additional effort where we take large mesoscale weather data, translate that down into a microscale over whatever terrain area we're looking at, taking into consideration the various terrain effects, vegetation, surface roughness, moisture, all those different aspects, to, as I said earlier, to really understand exactly what the effect of a given set of wind that we're monitoring from our set of weather stations is across the entire swath of the transmission line. Now we can deploy this system as just a standalone for a system operator to just look down at and make sure that they've got potentially some additional headroom if they need for some type of emergency situation. We can also fully integrate it into an energy management system. We've already got some history with operating and interfacing directly through Pi Historian. So it's a pretty simple thing for us to be able to come in and, if you want to automatically update any of your EMS calculations across your entire system, we can set that up for you as well. And of course, one of the most innovative aspects that we feel anyways about our approach to dynamic line rating is the fact that our approach is extremely scalable. With just the small investment of a few additional weather stations, which are optimally located as part of our computational fluid dynamics analysis, we can add a substantial amount of additional lines for a given application. And the real kicker about it is that because we're using large-scale weather information, we can also forecast whatever that rating might be in the day-ahead time frame, which has some real interesting impacts, we feel, on the operation of electricity markets in a bigger, broader scale.
Gotcha. And can you maybe go into a little bit more detail here?
Yeah, so here's a similar graph. Actually, I think it's the exact same graph. But what we've got over here on the right-hand side of that is an example of the economic dispatch stack of a handful of utilities. The one that's actually colored in this example is ERCOT. And why this is important is because within any kind of the wholesale electricity markets, so the ISO regions, RTO regions, things like that, where you've got a central system operator that's dispatching a huge swath of generators, anytime there's any type of transmission constraint within that system, what it forces is the system operator to then dispatch a higher cost generator. This is an unfortunate situation because this goes back to the problem that we were talking about earlier of this creates inefficiencies in the overall electricity market and basically forces additional costs to be shifted down to consumers because now you're using less efficient generation to meet the same power demands because of some constraint somewhere in your transmission system. So by being able to apply day-ahead forecasting and understand what those line ratings would be in the day-ahead time frame, it allows system operators to pre-position their generation stacks in advance to have the most efficient set of generators operating and minimize cost to consumers.
Perfect. And I know you guys have spent some time working with NYPA, and I think this is a really interesting example to bring up because just to frame how this technology is already being used and evaluated by key customers who are really known for spearheading new technologies.
Yeah, so a little bit of information on a pilot project that we currently have going on with NYPA. It was funded by NYSERDA, the New York State Energy Research and Development Authority, as part of their effort to help unlock additional clean energy throughout the New York region. Fundamentally, what we're doing is working with NYPA to fully demonstrate and integrate the forecasting application of a dynamic line rating system. Currently, we're testing one of their lines. It's about a 74-mile line, but it's also interconnected in an area with a pretty substantial amount of wind generation. It's a fairly old line. It's been around since, well, I shouldn't say fairly old line in historical context for transmission lines. It's kind of a newbie, being that it was built in the 60s. But it's seeing additional use and congestion due to all the renewable energy that's being deployed in the area, as well as changes in flow patterns that have been going on. So we're currently working with them. Right now, we are currently utilizing some existing weather stations to do the initial training of our computational fluid dynamics engine. We just had an update call late last week, and we are having some weather stations, hopefully that'll be shipped out in the next few weeks and then installed along the line, hopefully by early January. Then we'll start incorporating those data flows in for some additional refinement in the computational fluid dynamics algorithms. Then after that, we'll be able to use that weather information as well as forecasted weather information to start providing an actual forecasted line rating for that line. And we're hoping that this continues to go well. So far, we've had some good feedback from NYPA And we would love to see this project be able to expand to more lines and fundamentally, ultimately get fully integrated in their entire EMS system.
Gotcha. Now, yeah, we'd love to have you on a webinar later just to talk about some of the once this project deploys, to talk about the value. So best of luck with the rest of this project. One of the things that keeps coming up throughout this material is just this need for data, right? For forecasting, for making sure that those forecasts and analyses are highly accurate, right? There's a tremendous need for data, and this is kind of where Cognite comes in. So I'd kind of like to shift the focus to Francois. And what are some of the best practices here from a data infrastructure perspective? What's needed, and where does Cognite come into play?
Sure. Well, I mean, what we just heard is really fascinating, right? Having a dynamic line rating that is based on fairly non-intrusive methodologies, and at the same time allowing you not only in real-time dynamic line rating, but forecasting potential is huge. But as you highlighted, there's a need for more and more data sources. The more data sources, the more accurate. And also you will want, of course, to start integrating. And as you start doing forecasting, you will want to know what generation you have online to understand the impact. So we're quickly seeing that you need to build an infrastructure that not only will be able to bring you a lot of data sources, potentially dynamically add new data sources as time goes, because you refine elements or because the circumstances on the field are changing. Maybe the 60s lines gets a maintenance overhaul, and you get new capacitors installed. I mean, there will be changes here on the field, right? And so it becomes you have a high value model. A high value model that works when it's well integrated with the rest of the infrastructure. And you have a high value model that you want to scale across all your lines, because that's really where you will reap most of the benefits. And then that's where it fundamentally shifts from a modeling exercise to a scaling exercise. And that's where this idea of data infrastructure comes into play. And that's why I think what WinSim has developed is fantastic, and that's where at Cognite we're super excited, because that's why we are here. That's why we were born for the industries, to help scale these things. And you go from at the start of it looking at data mobilization. So that's the first thing you're looking at, identifying data sources, removing them from their silos, taking into account what Jake mentioned in terms of data security, which is going to be a big part of the conversation. And you need to then make sure that data, which is very often locked as well by vendors, is going to be made available and in an understandable fashion to the models. And once you have done your data mobilization, then you can move you can move to your data modeling and analytics and cataloging. And there what you find is that the data is there, but you need to still be able to govern that data and model it in a way that can be consumed easily by your models. You're going to have to make sure that it is trustworthy, because you will take operational decisions based on that data. So you will have discussions around data quality, around the whole traceability of the data and the decisions taken. And you will have the challenge that now you've done it for 70 miles. That's great. What about the next 1,000 miles that I want to deploy it on? So you will need to present the data in a format that is going to help the model scale across your full 1,000 miles. So that's the model will be very easily deployed across huge section of the infrastructure. And this is what we see in the second wave. And as you progress in the second wave and the models are generating insights and forecasts, as Charlton was talking about, then you also want to make sure that insight is captured so that it can be reused to create new operational insight or new decisions based on what the model is outputting. And that's where you move really to the last phase, which is the deployment and the capture of the value of your infrastructure as you're integrating these insights into decision cycles. So that's really what we're seeing when we're looking at operationalizing models at scale, and that's really is the journey that we're walking through with our customers.
I think it's really interesting to kind of show this as well in context of a knowledge graph. Can you maybe understand, help us map the underlying um, structure of the data so that it supports that journey?
Sure. So there we're looking at how do you represent effectively all the data sources that you need to bring in, and how do you make sure, as we were discussing before, these insights that are going to be generated by the dynamic line rating, how do you make sure that they're captured in a way that makes sense so that other programs, other algorithms can leverage them to make the actual decisions on what's going to happen on operationally. And typical structures that are tabular structures have their limitation, or hierarchical structures have their limitations. What we see is that to really represent well the dynamic nature of not only the sources but also the simulations, then we quickly move to data models that are looking like graphs, these graph solutions help represent the best possible way the physical worlds and all the relationship that may exist in this physical world, and really the ability to build this model and maintain them and govern them and enhance them with the results of simulation, like what WinSim is doing, is really what helps understanding the network and navigating the network in the most efficient way.
Gotcha. So as I kind of understand that, so that it's architecting the data so that it can be usable by machines, by algorithms, by simulations in the way that a human might think about that data.
Exactly.
So it's really, really interesting there. There's a little bit more under the hood here, right? There's especially if we're thinking about customers going through those different phases of maturity. Can you maybe share a little bit about what this architecture looks like and what users we enable through that?
Sure. So that's a very crude representation of it, but by and large, what we're looking at is again the first phase of mobilization, where you're looking at de-siloing and fusing together a multitude of data sources. So liberating them from the silos, making sure that they can be consumed and represented for usage. Then comes the contextualization steps, which effectively will start reconnecting this data together around a model like the one we just saw, right? A graph-like representation that is going to be understandable and queryable by machines, but also by humans. That there's a meaningful way to ask a question to your model, and that contextualization steps then basically give room to the data catalogs and the data sets, and that's when the data can start being accessed and consumed by users, and that will be data scientists, which may be working with some of the modeling tools, which may be working with their own models or enhancements of the models we are discussing today. But also, there's a huge amount of value once these insights have been created to actually visualize them, integrate them into standard tools. So there you're looking at traditional analyst tool like TIBCO, Tableau, Grafana, Power BI. So the standard visualization tools that are there in the enterprise. But and more than anything, you also want these insights to also trickle down to operation, and that's where the power lies really when you start. When you start really giving access to the operation for the operators to the insights that have been generated based on the data, and we're seeing a number of occasions where actually there's now a closed loop back to the control room, back to the command centers, where day-to-day decisions are made by the operators based on these models, based on these machine learning models or physics-based models that are generated in the backend.
Gotcha. Now, I know we're definitely in an industry with a lot of change, right? A lot of change that is accelerating very, very quickly. How is Cognite approaching things differently, and how does that represented in the product?
I think one of the main realization was exactly the reason why we're here. It's because there there are a lot of innovators out there, and the solution is not going to be a single monolithic solutions, ranking from the data all the way to the insights and operations. So it has to be the way we approach the industrial data challenge has to be an open-minded one. It has to be enabling innovative company like WinSim to actually thrive, deploy, add value to the operators. And I'm saying that because we started in the oil and gas industry pretty early on, and then we moved to the utility, and we realized that there was a very strong lock-in for historical vendors. So there was huge barrier of entry for innovators, and that clearly goes against the benefits of the actors in the field. So this idea that our main job is to make sure that data is liberated, that it is meaningful, and then that as many innovators, whether inside the company or in collaboration with third-party actors, can actually access and create new insights, create new value, is really core. A few other things as well is that it's pretty clear that if you come and you say that you're going to start wanting to change the landscape, whether it's the IT landscape or the operational landscape, you're probably in for a few decades of work. So there's this understanding that the reality is as it is out there. And we talked about data quality. Well, that's what it is. Now, what you can do is try to help fixing it and rebuilding some of these models. So the fact that it cannot come and make an assumption like that half of the infrastructure needs to be replaced is extremely important. Jake made a very good point. We work with extremely sensitive operations, whether that's grids, national grids, or it's natural resources operations, and so security is always at the heart of it. And there is a demand, a justified demand, and a fairly strong understanding now of what it takes to build a cloud-based infrastructure that is both secure and still tailored for heavy industries. And the last point I'll touch upon is maybe this idea of governance and data transfer. So you need to make sure that there's overall a way to manage the lineage, the way the data is going to be modeled, who is going to have access to that data, and be able to orchestrate these things. And that, I think, is something that comes as you try to operationalize things. It's not the first thing you think about, but without it, you're not going to be able to scale. You're not going to be able to actually trust at scale that your solution is going to hold.
Gotcha. That makes a lot of sense, Francois. And I think kind of if we move forward, I'd love to kind of think about this as one solution stack, right? So if we pull this all together, kind of handling back to you, Charlton, what would you say is the value proposition here of WinSim and Cognite Data Fusion working together?
Fundamentally, it would be the seamless integration of new data and new information for system operators that really helps to address and bring to fore all these capabilities that understanding what's going on with your transmission system can really have, as far as increasing capacities for renewables, removing congestion, maintaining safety and resilience, even things like small things like just identifying critical spans. And making sure that all this information is secure, maintained, and fully actionable, because all the information in the world doesn't do any good if it's not fully actionable. And that's fundamentally what we're here to do, is present actionable information so that system operators feel comfortable and take that information, utilize it, and provide the benefits that it can to the system, and make sure that those are able to bear fruit.
Gotcha. And then Francois, kind of the same question to you. What are you most excited for with this partnership, and where does Cognite Data Fusion really support WinSim's efforts?
Well, I'm first and foremost excited by the dynamic line rating application. I think it's brilliant. It solves a pretty dramatic needs out there in the field, and that's always a very healthy way to start looking at a partnership. This is extremely meaningful, even when you start. I mean, not only for the dynamic line rating, but also all the forecasting potential. It's a huge add-on and value for the industry. And then obviously what makes me very happy is that's for Cognite, this is exactly what you want to help scaling. It's a problem that will need a lot of data. It's to solve. It's a problem that will need good governance, and it's insights that you will want to capture in order to trigger tons of other actions and data-driven decisions. So it's really a perfect fit in that sense.
Hey Gabe, I might inject something real here.
Sure.
You know, when I first learned of Cognite, it came by way of an industry partner that we have now, California Energy Commission, and some offshore wind digitization of development. And I says, oh boy, where are they from? You know, who's getting into this digital twin stuff? You know, and I started looking into it, and I started asking questions. And the Western Interconnect has its challenges, and we've got loss of generation and potential deep water offshore wind. And I thought, wow. And then I had a conversation with Donna and Charlton, and I thought, and they're, oh yeah, we're talking to Cognite, we're very well aware of this. And I thought, here we go.
Thank you.
Gotcha. Well, I think that pretty much starts to wrap up the content, and we'll move to questions here in a few seconds. But some of the things I just wanted to really bring forward is that as we think about this problem and how Winsome and Cognite are addressing it, there's really this big opportunity to double down on existing infrastructure, make it more efficient, and reduce unnecessary new spending on capital investments. So I know there's kind of this balance here. I know a lot of budgets are being cut and everyone's got a lot of eyes here, but I think this opportunity to better leverage our existing infrastructure is hyper sustainable, and it really starts to depend on just using data better, right? Using data better, using data smarter, and using data in some of these really sophisticated applications like simulation and dynamic line rating. And then, if we think about this holistically, while the application area is being solved well, we still need to think about scale, because that's the point at which this becomes economical, becomes valuable on a broad scale. And I think we still need that right data infrastructure, the right methods to bridge this big gap from so much data, so much industrial data, and the emerging applications and technology that are addressing really very real, very significant problems in the space. So if we just kind of think about extending this conversation, if there's additional inquiries around dynamic line rating and all the work that Winsome is doing, Charlton will be your contact for that, and his information's there at the bottom of the page. And then if you think about the data operations and then contextualization and the infrastructure side of the house, our contact for that is Andy Schechter. So again, definitely start putting your heads together on this, and I think we're really excited to have announced the partnership and really excited to see where this goes in 2021. So I'm going to go ahead and jump into questions here real quick. So if you have questions that haven't been answered yet, feel free to bring them up. I think the first question that came in was kind of directed toward Charlton. And the question is your approach to dynamic line rating compatible with other DLR technologies? Yeah, that's the question.
Okay, great. Thank you for that. Fundamentally, yes. During the initial development of the technology, we had done a little bit of side-by-side testing with some other approaches to dynamic line rating, kind of as a verification and validation of both types of approaches. The approach that we were utilizing here as part of the WinSim Powerline offering, as well as a different approach that we were testing against. But it's actually something that we're really looking forward to potentially in the future. Is we would love to. We're already in a little bit of discussion with some of our cooperation. I think I said that correctly. To look at ways that we can take our weather-based approach, potentially couple it with one of the more physical-based approaches or device-based approaches, and figure out what fusions can come together and how any of those can work together to result in a better overall product. So yeah, fundamentally, yes, and want to be doing some more of that work in the future.
Gotcha. Great. So I think this question is more directed towards Jake, but from INL's perspective, what is on the horizon, and what do we need to be thinking about?
Innovation. I think the group here isn't new to that. I think you've got some very fast-paced, nimble, kind of commercial offerings and capabilities. And to kind of expand on Charlton's point there are many technologies that are out. Basically innovation is our thing. And we're excited to work with fast-paced companies like yourselves. What's on the horizon is just more. I mean, don't be afraid of change. I think that's the biggest message here is all things are possible.
Sure. And I think this next question could probably be addressed maybe by each one of you, but what is preventing dynamic line rating from being adopted at scale? I think we talked about this a little bit, but curious to go a little bit deeper from each of you.
Fear, uncertainty. And that's, I'm serious. The electric utility industry is very risk adverse, and they need to be. I think wide scale adoption really depends on consistent messaging and proof. You just need to demonstrate that it's possible. Load forecasts, that is not new. Generation forecasts, that's definitely not new. Transmission line rating forecasts, why should that be new? Right? And so I think it's just that barrier of dealing with uncertainty. It's a new process. Adoption, right? We are all humans. We like our comfort zones. And when you think about a control center, the dispatch and operations guys and gals, getting over that uncertainty, dealing with the fear of, I've just never done this before, and I think there's a lot of evidence that the technology is sound, ratings can be rated dynamically, forecasts can be trusted. Don't be afraid of change.
I would say to add to Jake's points there, I think one hindrance that we have, at least here in the U.S., is a bit on the regulatory side. We've got some disincentives that currently exist for utilities to make innovative investments like what we're talking about here. Fundamentally, I think most utilities would much rather spend $100 million, $1 billion on building a new 345 kV line, which, being a power systems engineer myself, I think transmission lines are gorgeous. I'd love to see more of them everywhere. But fundamentally, it's a tough sell. We've got a few activities currently going on at the federal level, being led by the Federal Energy Regulatory Commission. There's two different potential rulemakings under consideration to potentially take some of the benefits and the savings that can be brought about by dynamic line ratings, and allowing the utilities to capture some of that potential revenue as a nice incentive. There's also another effort going on, just broadly trying to have the industry reevaluate how it currently does static line ratings and line ratings in general, add some more clarity to that, and potentially force folks to start utilizing some newer information and be a little bit more nimble in how they're approaching things. So I think depending on where those two rulings end up going, I think that will hopefully help eliminate some of the barriers that we're seeing right now, beyond the comfort issues that Jake had already mentioned.
Yeah, and I think the comfort issues, motivations will come from urgency, and right now in the U.S., offshore wind is that energy disruptor. It's coming in big swaths. I've actually been surprised, honestly, at how fast the U.S. has been interested in adopting that. Well, maybe not too surprised, but I'm excited to see it, and I think that's an energy disruptor in the U.S., and that's going to motivate some transmission, distribution, kind of operational changes, and DLRs are going to be right there.
Great. And Francois, is there anything else you want to add to that as well?
No, I think that both Jake and Charlton are better positioned to talk about the scalability on the dynamic line rating simulation. What we have seen is also there is this fear of change and the incentive, which makes sense. Also, when it comes to technology investments and SaaS investments, which may not be directly related to capex investments. So that certainly has been something that has been slowing things down from a systemic perspective, nothing technical about it.
Gotcha. Yeah, general change management is difficult for sure. I think we've got one more question here for you, Francois. It's basically, if we're to start a data infrastructure project, like where do we begin? It seems like, and I hear this a lot as well, right? There's a lot of different places to start. How do you start to tackle this big problem?
I think what we're talking today is a great place to start, right? You start with how do you eat the elephant? You start by looking at a use case that makes sense business-wise, and then but in the back of your mind, you need to think in terms of scalability beyond that. And I think today the case was made pretty eloquently that dynamic line rating is not, is valuable in itself, but it's also valuable in conjunction with a lot of other things. So it should be a great incentive to actually drive a project like that in the context of building a solid data foundation to run the operation and the grid. And we have, we have tons of examples. So happy for the person who asked to go into some of them, right, as to what it means, what next, how do you go from there. But just building that foundation and allowing this insight to be captured is already a win. And then beyond that, then it's easier then to start adding more data sources, different, additional ways of modeling the data and solving more use cases. Jake mentioned that, fundamentally it's the same software, it's the same platform, exactly the same technology that we're using to solve offshore wind problematics, to solve interconnection problematics with some of our grid customers in Europe. But starting somewhere with a clear business case is always going to be a good catalyst and a good focus for such a project.
Excellent. Well, thank you, Francois. And just a big thank you to all three of our panelists. Again, thank you for your insights. Thank you for participating today. Again, a reminder, if you're looking for more information, I have your contacts here at the bottom. And again, just on behalf of Cognite and Winsome, thank you all for attending, and we hope you have a great rest of the afternoon.